All right, let's take a look at section 4.2 on the trigonometric functions. We're trying to understand the trigonometric functions using the unit circle. Okay, so unit circle is typically look like this. One unit. One. Okay, so you draw a unit circle. And we can understand the trigonometric, all 6 trigonometric functions using the unit circle. Okay. We're going to identify a unit circle and describe the relationship to real numbers, and we should learn how to evaluate trigonometric functions using the unit circle. Use domain and period to evaluate sine cosine functions, and using the calculator to evaluate the trigonometric functions. Okay, so let's take a look at the unit circle really quickly. There are 2 historical perspectives of trigonometry and cover different methods of introducing the trigonometry functions, but unit circle is one of the most important ones. So basically, what we're trying to mention unit circle is a circle given this equation x squared plus y squared equal to 1. Here center it's 0, 0, and the radius equal to 1. Okay, center radius, that's given, and this is a typical unit circle. If you look at any point on the unit circle, you can use x, y to represent on the surface of a unit circle. And if you're connecting this point towards the origin, then we'll be able to manually create a right triangle right here to a perpendicular line towards the x-axis. Then we create a right triangle here, and then this angle theta here is the main focus of the trigonometric function. Then we could define sine, cosine, tangent, cotangent, secant, cosecant using this angle theta. Also together with the x coordinate and y coordinate from the order pair. So this is what we are saying. If you rotate the angle counterclockwise, in this case this is counterclockwise, meaning we're going to have a positive angle. Counterclockwise yields positive angle. And right here we create an angle clockwise. So this is clockwise. Basically follow the same direction as the clock, regular clock. That's why it's named after clockwise. And also we end up with a negative angle. If you rotate the angle clockwise, the angle will be negative angle. And so this arc length here has something to do with the angle itself, right? So this angle covers this amount of arc length. Similarly, right here, this angle covers this amount of arc length. So they have a corresponding relationship with each other. In general, each real number t also corresponds with a central angle theta. That means arc length, interpretation arc length, and the angle theta, they are related. And when radius equal to 1, the angle theta in radian measure, right? Theta here must be radian measurement. Then angle theta is the same thing as the arc length itself. So when radius equal to 1, meaning we're talking about a unit circle. So for unit circle, arc length s is the same thing as angle theta in radian measurement. Okay. Now let's take a look at trigonometric functions. We have 6 of them. 6 trigonometric function. And typically you call that sine, cosine, tangent, cotangent, secant, cosecant. Sine, cosine, that's the first one, second one, third one. That's sine, cosecant. The third one will be cosine. Fourth one, secant. Tangent. Fifth one, cotangent. Sixth one. The reason they put in such order because sine and cosecant are reciprocal. So that's a relationship between the sine and cosecant. The product of those two functions equal to 1. So sine theta times cosecant theta equal to 1. Cosine theta times secant theta equal to 1. And tangent theta times cotangent theta equal to 1. That's why they go hand in hand, right? Hand in hand, yeah. So we just use a simple version of this. Sine, we use sin to represent sine. Cosecant is CSC. Cosine using COS. Secant is SEC. Tangent TAN, and then cotangent COT, respectively. Just write it as a simpler version. So since they are reciprocal, so if you know one of them, you know the other one. Okay. If you know sine theta, then the value of the sine theta, then you'll be able to find out the cosecant theta. You can also write this as cosecant theta equal to reciprocal of sine theta. Okay. And secant theta equal reciprocal of cosine theta. And then tangent theta equal reciprocal of cotangent theta. Now, again, let's look at the unit circle one more time. So this is unit circle. Now, on this unit circle, let's say we have any given order pair here, right, comma x, comma y, 1, 1, -1, -1. Now again, in order to define all these 6 trigonometric functions, let's assuming t be the angle here. Okay. Now again, we create a right triangle here by drawing a vertical line perpendicular towards the x-axis. Okay. Now create a right triangle here. So in this particular right triangle here, this right triangle. Okay. Now x coordinate goes here, y coordinate goes here, and then unit circle. So radius is 1 unit. So now we can define sine t. Sine is always the opposite over hypotenuse. Opposite over hypotenuse. So it's going to be opposite y over hypotenuse 1. So sine t equal to y. Cosine t is adjacent over hypotenuse. So adjacent is x over hypotenuse. Adjacent of the angle t is x. Hypotenuse of angle t, that's 1. X over 1, that gives us x. And you can also write a tangent angle t. Tangent is opposite over adjacent. Opposite is y over adjacent x. And then cotangent t is adjacent over opposite. Adjacent is x over opposite. Opposite of y. So adjacent x over y. Yeah. And then also we look at this cosecant first. Cosecant t is hypotenuse over opposite, so it's 1 over y. And secant t is hypotenuse over adjacent. Side, so it's gonna be a 1 over x. Okay, that's how you find all these 6 trig identities in a unit circle. So just corresponds with all of this. Right? Yeah. Okay, so that's how this 6 trigonometry function was defined using the unit circle right here. And we have some special angles. When angle t equal to pi over 2, that means it's located on the point is located on the y-axis. Point is located on the y-axis. On the y-axis, x value equal to 0, y equal to 1, right? Okay, and then that follows tangent pi over 2. Tangent is, if you look at the previous one, tangent is y over x, so y is 1, x equal to 0, so that's undefined. Okay, also secant pi over 2. So if you want to draw the unit circle, understand this, you can do that really quickly. See, this unit circle, the point is right here now, and this order pair is going to be 0, 1, and then secant, if you go back to the previous slide, secant is 1 over x. So 1 over x is 1 over 0. Yep, so that's undefined as well. This is one of the special angles that the tangent and cosecant are undefined. And cotangent, cosecant are not defined when y equals 0. I mean, t equals 0, if you look at right angle here, unit circle, and we're looking at these points right here, then we know that the sine here equal to 0, right? Cotangent, and the order pair here will be, is located on the x-axis, the y value equal to 0, so 1, 0. Okay, so this point is 1, 0. This is x coordinate, that is y coordinate. Okay, and then cotangent, this angle t, if you look at the formula we derived, cotangent equal to x over y. So x value is 1, y value is 0, so again it's undefined. Okay, and cosecant t, cosecant is 1 over y. Okay, so 1 over y, when y value equal to 0, so it's 1 over 0 again, so that's undefined. So we can use what we defined from the earlier slide and to determine this special the trigonometric functions, the special angles. And now if you look at this, the unit circle is divided into 8 equal arcs corresponding to t value of 0, pi over 4, pi over 2, 3 pi over 4, pi. So basically you split the whole circle into 8 equal pieces, and that means that at this point right here is pi over 4. Okay, So how do we get radical 2 and radical 2? We can use a Pythagorean theorem, assuming this is angle t, right? And now we know that this is 40 t value equal to pi over 4. That's 45 degrees. And this is t 45 degrees, and this angle here is also 45 degrees because this is 90 degrees. Okay. So basically we have equilateral triangle, so you can assuming this is x, right, coordinate, that's y coordinate, and then here because it's equilateral, so x equal to y. So we basically could use this to find out the setup of using Pythagorean theorem to set up the equation to find the, because it's right triangle, so using Pythagorean theorem, that means x squared plus y squared equal to or r squared, which is 1 squared. So here y equal to x, so replace y with x, so you get x squared plus x squared equal to 1. So we get 2x squared equal to 1, and then x squared equal to half. And when you take in the radical here, let's continue from here, x equal to plus minus radical half. But since it's in the first quadrant, so we only keep the positive values. So here x should be just radical half. If you simplify this, x equal to first quadrant, right? Both x value and y value must be positive. So it's radical 1 over radical 2. This is 1 over radical 2. Then you rationalize the denominator. You multiply radical 2 on both top and bottom. You get radical 2 over 2. So that's how they end up with this value, radical 2 over 2. And since x equal to radical 2 over 2, then y must be equal to radical 2 over 2. Okay, because x equal to y. And we use a little bit of geometry to help you, get all this, the exact coordinate at all those special angles. In the second quadrant, since the first quadrant both positive, that's good. Second quadrant, x must be negative. Okay, x coordinate must be negative, and then y coordinate must be positive, right? So this is positive, that's negative. And that's why you just have to change the sign to negative here. In the third quadrant, both negative. Both x and y is negative, so that's why values, both negative values. In the fourth quadrant, x is positive, y is negative. This is both. Yeah. Okay. And this is one of this very special angle. Let's take a look at another type of special angle, which is you divide a unit circle into 12 equal arcs, and then each, that means 360 by 12, 360 degrees by 12, and that's one revolution by 12, that's 30 degrees. So each partition is 30 degrees. That means this angle here is 30 degrees. Okay. Now, this is 30, that must be 30 as well. Okay. So now let's just take a look at this order pair right here. Let's see how we end up with this coordinate right here. So basically, what you can do is connecting these 2 points right here. Okay. So the angle here is 60, and radius are equal to each other. This is 1, that's 1. So we get equilateral triangle. That means that the sum of the triangle is 180 degrees, take away 60 degrees, remaining is 120, but they're equilateral, so those two angles equal to each other, so it's 60 degrees and then 60 degrees here. Okay, so we get all three sides equal to each other because they're all 60 degrees. So right here, if you see this line is perpendicular to this, so it will cut this into half and half. So if this is 1 unit, then the total length here must be 1 unit. Half of it will be half unit. Okay. So if this is half, right here, this is half. this half of it, this half, and then we'll be able to find out this side right here, because this is one that's half. So we don't know x, so using Pythagorean theorem, and let's set up the equation, solve for unknown. So x squared plus half square equal to 1 square. So this is x squared plus a quarter equal to 1. So x squared equal 3/4. Now again, since it's in the first quadrant, x must be positive. So x equal to positive radical 3/4. The x equal radical 3/2. Okay, and x equal to this, and the y value, we already know that it's half unit, so half. And that's how they end up with this order pair. So basically, all of this special, all these points, you can use geometry to find out all these coordinates. If you partition the whole circle, the unit circle, in 12 equal arcs. Okay, let's take a look. Verify the points on the unit circle. Know that radical 2 lies on the line y equal to x. X4, yeah, we actually went over this earlier. I use a geometry to, so geometry is very useful in terms of understanding the trigonometry. And that's just another way of understand how we get this radical to radical 2 by expanding in the earlier stage. Similarly here, right? If let's say I'm going to pick another one, 60-degree angle. Okay. Similarly here, if you want to get order pair on this, meaning this angle is 60 degrees. Okay, now if you connect these 2 points, now we know this is 1 unit, and we can cut this triangle here, draw from the right triangle here. So this is 60 and radius, and this must be 60 degrees, this must be 60 degrees. And now this perpendicular line towards the x-axis cut the bottom into half and half. So this x coordinate must be half. And then the y coordinate, we can use the Pythagorean theorem to get a y coordinate. So a half square plus y square equal to 1 square. There's a quarter plus y square equal to 1. So we're looking at this. So y square equal 3/4. And again, it's in the first quadrant, so y value should be radical positive 3/4. So y equal radical 3/2. That's why they get x value is half, right? We find that x coordinate is half, y coordinate is radical 3/2 using the Pythagorean theorem. Okay, so now evaluate the 6 trigonometric function at each real numbers. The first one is t equal to pi over 6. Pi over 6 is 30 degrees. So if you want to get a sine t, you can draw a unit circle, right, to try to understand this. Again, draw the unit circle. Pi over 3, if you want to turn into a degree measurement, that'll be 30-degree angle. So that means we're looking at this angle right here, 30-degree angle. And we want to find out the sine t, cosine t, tangent, cotangent, secant, cosecant. Now again, you draw this. Now for the mirror image on the bottom half of it. Okay, do this. Right. Now you're connecting this all the way to the bottom. Okay. This is also mirror image, meaning this is all 30-degree angle. So 30, this is 90, then this must be 60, this must be 60. So all 3 sides equal to each other. And if you look at perpendicular right here, this is 1 unit, 1 unit. Then this perpendicular cut it into half and half. So this right here is half. On the bottom is also half. Okay. So this is half, this is 1. We'll be able to find out that this x coordinate here must be radical 3 over 2 using Pythagorean theorem. Okay, so now we'll be able to find out sine t. Sine t is opposite half over hypotenuse half over 1, so it's half. Cosine t is adjacent is radical 3 over 2 over 1, so it becomes radical 3 over 2. And tangent t, it's opposite over adjacent half over radical 3 over 2. So this is a complex fraction, so you do half times, use the reciprocal of the bottom fraction, cancel the 2, you get a 1 over radical 3, and rationalize this by multiplying radical 3 on both top and bottom. So we end up with a radical 3 over 3. Yep, that's 3 of them. The other 3 will be the reciprocal. Since we know sine t, then we know cosecant t will be reciprocal of this, so it's 2 over 1. That turned out to be 2. And then cosine t will be the reciprocal of secant t will be reciprocal of this, so it becomes radical 2 over radical 3. Once you rationalize this, it becomes 2 radical 3 over 3. And then cotangent t is the reciprocal of the tangent t, so you find reciprocal of this, so it's radical 3 over 1. Using this, it's easier to use this to do a reciprocal, right? That's why we get that. Okay. Yeah, this is basically how you utilize draw the unit circle and then go from there. But definitely, you can just follow the formula to get it, no problem. Just like what we did earlier, apply the formula. We know x coordinate, y coordinate, then get all these 6 identities. And now let's take a look at 5 pi over 4. All right. So now again, draw the unit circle. Looking at 5 pi over 4 unit circle. 5 pi over 4, if you want to turn into a degree measurement, should be pi is equal to 180 degrees. So it's 5 times 180 degrees over 4. That's 900 degrees over 4. That turned out to be 225 degrees. So this angle must be located in the 3rd quadrant, right? So this is 180, another 45. So let's cut this into half and half. So this is 45. So reference angle is 45 degrees. And we know for 45 degrees, if you draw the right triangle here, these two equal to each other. As this is in the 3rd quadrant, so both x coordinate, y coordinate is negative. So negative radical 2 over 2, negative radical 2 over 2. Again, you can use Pythagorean theorem to find this, right? And once you know that, then the rest of them should be straightforward. We're looking at this angle here. So sine 5 pi over 4 will be opposite, which is negative radical 2 over 2, y value, over 1, right? So that turned out to be negative radical 2 over 2 over 1. So it's negative radical 2 over 2. Okay, and then the cosine will be adjacent. That's also negative radical 2 over 2 over hypotenuse 1. So it'll be the same. So negative radical 2 over 2. And tangent will be opposite over adjacent. They equal to each other, so they cancel each other. It turned out to be 1. And then cosecant is a reciprocal of sine, right? So you just reciprocal that. So now we end up with reciprocal of this. Then we simplify that. You get negative radical 2. Secant is a reciprocal of cosine, so it's the same as a cosecant. Cotangent is a reciprocal of a tangent, so it's also 1. Okay. Now let's take a look at part C on when the angle equal to pi, meaning this angle is located on the unit circle. It's right here, right? Pi. This is a pi, radian. Pi is equal to 180 degrees. We'll look at the half of the revolution here. So the point is located on the negative side of the x-axis. And the coordinate here is located on the x-axis, the y value equal to 0, x value equal to -1, -1, 0. So this is the x coordinate, that's y coordinate. So if you use a formula, sine pi, sine 180 degrees equal to y equal to 0, right? Cosine pi equal to x, so that's why it's -1. Tangent pi is y over x, so 0 over -1 becomes 0. And cotangent, cosecant is undefined because it's 1 over y is 0, so it's 1 here, y equal to 0. So it becomes 1 over 0, that's why it's undefined. Secant is 1 over x, is 1 over -1, that turned out to be -1. And cotangent pi, again, it's x over y. And since y equal to 0, then it's undefined. And that's one of the special angle. Now here we have a negative angle here, meaning we're gonna go clockwise, go this way. So this is clockwise right here. This angle is -pi/3. -pi/3 is -60 degrees. 180 degrees over 3 is -60 degrees. Then again, if that is the case, draw a right triangle here. So this is half units here. And since it's on the negative side, it's negative radical 3 over 2. So the coordinate here, x coordinate is half. Y coordinate is negative radical 3 over 2. Okay, now we could find the sine, cosine just using so sine -pi/3 is equal to opposite over hypotenuse, so negative radical 3 over 2 over 1, which is the same thing as y value, negative radical 3 over 2. Cosine -pi/3 will be adjacent half over hypotenuse 1. Okay, so half over 1, which is half. And tangent opposite over adjacent, so negative radical 3 over 2 over half, that becomes negative radical 3. Okay, so the rest of them, again, you apply once you have the coordinates clear, then you'll be able to get the rest of them. Pretty straightforward. And then now the last topic in this section is about domain and the period of the sine cosine functions. So the domain for both sine and cosine, both of them will be -infinity to infinity. Okay, and then the period, original period is always 2 pi. Okay, all right. So the domain of the sine cosine function is the set of Oriel numbers. Oriel numbers indicates it's from -infinity to infinity, and then meaning all x values are possible here. And then the range, if you look at the range for the sine function, the range is from -1 to 1. Okay. Yeah, because this limitation of the unit circle. Okay, and same thing for cosine, right? It will be the same. So the x value, the y value here is between -1 and 1. So the sine t must be between -1 and 1 under the unit circle, because sine t equal to y, and cosine t equal to x. X value is between -1 to 1, then cosine t must be between -1 and 1. That also tells us the range, right? So range for both sine and cosine it's going to be from -1 to all the way to 1, including -1 and 1. Okay, these are some equivalent angles, right? So for example, if you have an angle pi/4, you can generate as many equivalent angle as possible by just adding 2 pi, 4 pi, right? Adding pi/4, 6 pi. You could also, you see, -2 pi, right? You could do that, -4 pi, subtracting 6 pi, so you can get infinitely many equivalent angles here. So for any given angle, you can create as many equivalent angles as possible. So that's what this chart tells us. And also the cycle, right? There's a cycle effect for sine, cosine, because cycle is 2 pi. You see, this 2 pi is significant adding one cycle, and then it's 2 pi. So that's why the period, called the cycle period, is also called cycle or revolution. And period is 2 pi for both sine and cosine, because sine t plus 2n pi is the same thing as sine t. And cosine, because t is the same thing. They are equivalent, so t is the same thing as t plus 2n pi, because they're equivalent angles. Okay, same thing for cosine. Here t is the same thing as t plus 2n pi. Okay, that's why cosine t plus 2n pi equals cosine t. And then the period, in this case, period must be 2 pi. And both functions are periodic functions. The definition of periodic function is function f is periodic if where there exists a positive real number c such that if ft plus c equals f of t, and in the sine case will be sine t plus 2n pi equals sine t. And here 2n pi is what we're talking about, c here, right? So you add in c, you end up with the same result. Then the period is going to be 2n pi. Okay. So that c becomes the period. Okay. So here c is the period of the function f of x, f of t. Okay. And we know that when a function is even, meaning f negative t equal f of t, when it is odd, and then f of negative t equal to negative f of t. And the original version is f of negative x equal to f of x, right? But now the variable becomes t. And similarly, this is for even function. For our function, f negative x equal negative f of x. Okay, and same thing here, so the variable becomes t here, so it's odd. So there are two even functions for all those trigonometric functions, cosine and secant. Cosine is even, cosine negative t equals cosine t. And then secant is even, because cosine is even, then secant is even. Alright, and then the rest of them are all R functions. So sine negative t equal negative sine t, cosecant negative t equal negative cosecant t, tangent negative t equal negative tangent t, cotangent negative t equal negative cotangent t. It's just cosine, secant are even. Right, remember that. And the rest of them will be odd. Okay. Now let's take a look at this example. Because 13 pi over 6 equal 2 pi plus 6 pi over 6, that means sine 13 pi over 6 equal this. That should be equal sine pi over 6, right? This is one revolution, one cycle, so that will be half. Okay, sine pi over 6, sine 30 degrees equals half. Negative 7 pi over 4, similarly, you adding it should be negative 4 pi plus pi over 2. Another way of looking at this is you can do this adding 4 pi. Another way is negative 7 pi over 2 plus 4 pi, negative 7 pi over 2 plus 8 pi over 2 is equivalent to pi over 2, right? So here you go, pi over 2. So it should be the same as cosine pi over 2. And cosine 90 degrees equal to 0. Sine 90 degrees equal to 1 and cosine 90 degrees equal to 0. Now sine t equals to 4/5. Sine negative t will be negative 4/5 because sine is an R function. Okay. Alright, so last thing is how to evaluate a trigonometric function using a calculator. So for example, if let's say you have cosecant pi over 8, that's the same thing as 1 over sine pi over 8. And that's how you input into the calculator sine pi over 8, and then using the inverse function x raised to -1, power to -1, and then you enter, you get a result. You should try in your calculator.